Welcome to the second part of the Equilibrium video podcast series that deals specifically with Le Chatelier's principle. In part one, we dealt with the effect of a change in concentration on the equilibrium. In part two, we're going to talk about changes in pressure. So stay tuned. Just want to review very quickly some of the definitions for equilibrium and Le Chatelier's principle. If a chemical system at equilibrium experiences a change in concentration, temperature, volume, or partial pressure, then the equilibrium shifts to counteract the imposed change and a new equilibrium is established. Continuing on with our review, Le Chatelier's principle can be used to predict what will happen to the amounts of the reactants and products when an equilibrium system undergoes a stress, which is a change. The value of K remains constant unless the temperature changes. Again, the value of K remains constant unless the temperature changes. Continuing with our review, our restatement. If a change is imposed on a system at equilibrium, the position of the equilibrium will shift in a direction that tends to reduce that change. This is a quote from Chemistry 7th edition by Stephen S. and Susan A. Zumdahl. I want to give full credit to them on this. But when we're talking about Le Chatelier's principle, the language needs to be very precise. Let's look at three changes that can affect pressure. One would be to add or remove a gaseous reactant or product. The second would be to add an inert gas. When we talk about inert gases, it could be something like an actual noble gas, which we also call an inert gas, neon, helium, krypton, or it could be just a gas that doesn't react with the gases that make up the equilibrium system. For instance, you could put nitrogen into a container that has certain gases in it that nitrogen doesn't react with, and so the word inert there just refers to any gas that you add that doesn't get involved in the reaction. The other way we can affect the pressure would be to change the volume of the container. Out of these three changes, only the first and third affect the equilibrium system. Change 2, adding an inert gas, would increase the total pressure, but it doesn't change the concentrations or partial pressures of the reactants or products. Looking more closely at the changes that do affect pressure, looking at number 1, adding or removing a gaseous reactant or product. I again want to quote from Chemistry 7th edition by Zumdahl. Increasing or decreasing the pressure of a gaseous reactant or product by adding or removing the reactant or product is the same as an increase or decrease in the concentration of the reactant or product. Predictions of the effect on equilibrium system are the same as one would predict with a change in concentration. Looking at the changes that affect pressure, number 3, changing the volume of the container. Again, a quote from Chemistry 7th edition by Zumdahl. When the volume of a container holding a gaseous system is reduced, the system responds by reducing its own volume. This is done by reducing the number of gaseous molecules in the system. The reaction will favor the side of the reaction that has the fewest number of moles of gas particles. Now, conversely, if the volume of the container is increased, then the reaction will favor the side of the reaction that has the greater number of moles of gas particles. So as you look at the balanced equation, you look at the coefficients for the gases, and that would tell you how many moles of gas particles are on each side of the reaction, the reactant side and the product side. If the number of moles of gas on the reactant side is equal to the number of moles of gas on the product side, changing the volume of the container would have no effect. So just something to keep in mind as we go forward. Let's look what happens in a real-life situation as we change the volume of the container. We consider the reaction N2 plus 3H2 yields 2NH3. If the volume of the system decreases, the reaction will shift right and form more NH3, reducing the overall number of gas molecules present. thus decreasing the overall volume of the gas. Another simple way that you can look at this is if there are fewer gas particles, it lowers the pressure. So if you look at changing the volume by reducing the volume, in which case the pressure would increase, the equilibrium system will shift to the side of the reaction that has the fewest number of gas particles because it would reduce that pressure change. So however you want to look at it, this is probably the most precise way of looking at it, which is written here. The other side of this, as we look at this same reaction, N2 plus 3H2 yields 2NH3. If the volume of the system increases, the reaction will shift left and form more N2 and H2, increasing the overall number of gas molecules present, increasing the volume of the gas. So that's a wonderful spelling of increasing before the overall number. I hope you enjoy that. I'm rather enjoying looking at that now. And if you can't laugh at yourself, life gets real hard and long. So you can join me in a chuckle on that. But if you increase the volume, if you remember back to Boyle's law, that at constant temperature and number of particles of gas, if you increase the volume, the pressure should decrease. So the equilibrium system shifts to the side of the reaction that would have more gas particles or more gas molecules. It would shift left here. So again, let's just continue to look at this same process, the Haber process. And here's a thermochemical equation. Here's the equilibrium constant expression. And let's go ahead and look at what the change in pressure would do here in a sample problem. So if the volume of the system decreases, how will the concentrations of the reactants and products be affected? And if you would go ahead and pause the podcast and make your prediction, write it down, and then come back and see if your answer agrees with mine. Okay, let's see if your answers match mine, and maybe even your enthusiasm will match mine. Let's take a look. Well, pressure increases because of the decrease in volume, so the forward reaction will be favored, the side with reaction with fewer gas molecules. So your concentration of nitrogen should decrease, concentration of hydrogen should decrease, and your concentration of ammonia should increase. If you agree with me, then you're in good shape because that's the right answer. Okay, let's consider another equilibrium system. Here we're having heat added to calcium carbonate solid, and we form calcium oxide and carbon dioxide. Remember, the equilibrium constant expression here contains only the gas. The solids are not included. So K is equal to the concentration of CO2, or K sub P is equal to the partial pressure of CO2. How will the amount of CO2 be affected by the decreasing of the volume of the reaction vessel? And wow, incredible grammar there. Just cross out the that you don't need. But if you'll go ahead and pause the podcast and answer that, and we'll take a look. All right, let's take a look at your answer. Pressure increases because of the decrease in volume. Therefore, your carbon dioxide concentration should decrease. Another sample problem using the Haber process. If the volume of the system is doubled, how will the partial pressures of each of the reactants and products be affected? So if you'll go ahead and pause the podcast, predict your answer, and come on back and we'll see how you did. Okay, if the volume of the system is doubled, how will the partial pressures of each of the reactants and products be affected? Well, if the volume is doubled, the pressure would decrease. So the equilibrium would shift to the side that has the greater number of moles of gas. So we're going to shift left. And so your concentration or partial pressure of N2 will increase. Your concentration or partial pressure of H2 will increase. And your partial pressure or concentration of ammonia will decrease. Let's try a your turn problem here. Consider the following reaction that reaches equilibrium at 520 Kelvin. H2 gas plus I2 gas yields 2HI gas plus heat. What will happen to the other reactants and products if A, the volume is decreased to half, B, the volume is doubled, C, the pressure is increased by the addition of an inert gas? State as well whether the equilibrium shifts left, right, or is unchanged. So if you will pause the podcast, write down your answer, and come back and we'll see how you did. For changes A and B, whether you increase the volume or decrease the volume, there is no change. Since the number of moles of gas particles are the same for the reactants and products, the equilibrium is not affected by the volume change. There will be no shift in this equilibrium. For part C, there is also no change. Addition of an inert gas does not affect partial pressures of the reactants or the products. Well, this is the end of part 2 of the Equilibrium video podcast series that deals specifically with Le Chatelier's principle. I want to leave you with a word to the wise from Bill Cosby. A word to the wise ain't necessary. It's the stupid ones that need advice. So I wish you well. Stay tuned for part 3.